First of all, 8255 is nothing but it is a peripheral. You can say it's a helping hand of 8085 microprocessor. With the 8255, we will get three 8-bit port, PA, PB, and PC. Port A, Port B, and Port C. If Port B also dividing into the two part, one is a PC upper, another is a PC lower. Each are 4-bit wide. So we can say two 8-bit port and two 4-bit port, like that. And you know, as you know, all of you know that what are the functions of right hand, what are the functions of left hand. Everything, you know, it is a noted. Every people is know what are the functions of right hand, what are the functions of left hand. Every people know how to write and all. So you in your brain, you know, some instruction is given. What are the functions of right hand? What are the functions of left hand? So that's similarly like that in a CWR. In CWR, what are the functions of port A, port B, and port C? It will be discussed. You know, how much, you know, which mode it will be worked, and which port will be act as the input, which port as act as output. It will be worked. So I'm coming into that particular point. So basically, CWR, full form of CWR. Yesterday I told.
Control word register.
Control word register. This is the 8-bit wide. This is the 8-bit wide. This is D7 and this is the D0. So in D7, in D0 to D7, this is called either if this bit is 1, then it's called IO mode. If this bit is 0, then it's called BSR mode. IO full form input output mode, and 0 full form BSR full form bit set reset mode. This bit all are is nothing but either 1 or 0. If 1, then it is IO mode. If 0, then it is BSR mode. Is it clear? It's clear to all of you?
Yes, sir.
Next, these two bit for mode selection means 0 0 mode 0, 0 1 mode 1, 1x means maybe 1 1, maybe 1 0. Mode 2. So basically mode 0, mode 1 and mode 2, 0 0 0 1 1x. That is the, you know, whole functions of these two pin. Either it's 0 0, either it's 0 1, other is 1 0. If I'm talking about the mode 0, then this pin is 1, it's a PA, it's a PC upper, it's a PB, and it's a PC lower. If 1, then it's input. If 0, then it's output. Similarly like that, 1 for input, 0 for output. 1 for input, 0 for output. PC lower, similarly 1 for input, 0 for output. This is also another mode selection for group B. Group B means this one under group B. If 0, then mode 0. If 1, then mode 1. Right? I will be coming into the example, then it will be clear to you. Mode 0 is a different name, is called bit set, simply IO mode. Mode 0 is nothing but a simply IO mode, simple IO mode. Mode 0 is nothing but a simple IO mode. Mode 1 is nothing but a handshaking mode. Mode 1 is nothing but a handshaking mode. And mode 2 is nothing but a bidirectional mode. Mode 2 is nothing but a bidirectional mode. Is it clear? Mode 1, you just write down. Mode 0 is name is input, simply input mode, input output mode, simply IO mode. Mode 1 is nothing but a handshaking mode, and mode 2 is nothing but a bidirectional mode. It's clear to all of you?
Yes, sir.
Sir, mode 1 के?
Mode 1 is a handshaking mode, and mode 2 is a bidirectional mode. Explanation में अभी आएंगे. ये तीनों मोड अंडर द IO mode. Remember, ये तीनों मोड है under the IO mode. If BSR mode, that will be described separate. It will be described, no issues. But it is under IO mode. What is the BSR mode? I will be described, no issue. Next, simple IO mode means sometime you will be some port may be used as an input, some port may use as an output. That is the function of simple IO mode. Some port will be used as an input and some port will be used as an output. That is the function of simple IO mode. Mode 1 is a handshaking mode. Mode 1 is handshaking mode. What is a handshaking mode? Handshaking, some handshaking signal will be there. Like, what is the function of PC? I'm just asking you, what is the function of PC? So just I am explaining like that. PC is nothing but a program counter. Yes, sir. The next instruction, yes, sir. To be executed, yes, sir. Stored into the PC, yes, sir. That is the function of program counter. Yes, sir. Who says the yes, sir? Yes, sir. कौन बोलेगा?
Receiver, हम लोग.
Yes, receiver. Means handshaking signal like that. Whenever I am sending a data, you give me a positive acknowledgement. So if you are not given the positive acknowledgement, I am sending the data once again. And this procedure will be continue and continue and continue. So just that's why I'm just telling you, for handshaking signal, first you give me a yes sir, then I will be sent another data. If you are not saying yes sir, I will be wait till you are given the yes sir. Otherwise, I will be send the same data once again. So this is called handshaking mode. Simple IO mode, there is a no handshaking signal, but in mode 1 there is a handshaking signal. Actually, port C mainly used for the handshaking signal. Next, mode 2 is a bidirectional mode. Bidirectional mode means either you see that either mode 1 is the input or output. To say port A is the input or output, port C upper is the input or output, port B is the input or output, port C lower is the input or output. But in mode 2, it can be used as a bidirectional. Remember, in mode 2 only applicable for port A, not applicable for port B. Therefore, port A used as a handshaking signal, and port C upper and lower, these two are basically used for handshaking signal. Port A will be used as a bidirectional port. Port C upper and port C lower used for the handshaking signal. Next, port B. Port B may be in that particular case either mode 0 or mode 1. Port B, if mode 0, then it will be maybe input output port, or it will be in a mode 1, so it will be in a handshaking signal mode, whatever it is. So mainly your important part is port 0, mode 0. That is simply IO mode. It's a very, very important. IO mode of mode 0 and BSR mode of you, it will be very, very important. I will be described today what is the IO mode and what is the BSR mode. First, I am explaining the BSR mode, then I will be coming again with an example. BSR mode. If I am talking about the BSR mode, then this bit should be 0. These 3 pin is nothing but a 000, then PC0, 001, then PC1, 010, then PC2. Similarly, dot 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 111 is nothing but a PC7. So how many bits are there? 1, 2, 3, 4, 5. So 6, 7, 6, 7, 8. Just 1, 2, 3, 4, 5, 6, 7, 8. This is no functions. As this is a no function, so we are put it over here 0. As this is a no function, so we are put it over here 0. Is it clear?
Yes, sir.
So how I am select the PC4? What will be the value? PC4, what will be the value? बोलो बोलो PC4 के लिए क्या होगा?
100.
100 100, so that will be PC4. So 0 0 0 0 PC4 100, right? Next,
Yes,
this
sir.
bit is very important, whether you want to set or reset. If 1, then set. If 0, then reset. So if I want to PC4 as a set, set means this bit will be 1. Set bit means this bit will be 1. So 0 0 0 0, this is a no function. 1 0 0 for PC4. It's for PC4. It's for BSR mode. It will be 1 for set. It's clear to all of you?
Yes, sir.
Any queries? If you have, you can ask me. This is only for 8255 at BSR mode. This is a BSR mode. BSR mode of 8255. Any queries? Can I proceed? Is it
Yes,
clear
sir.
to everyone?
Yes, sir.
Yes,
Okay.
sir.
Next, this is the BSR mode of 8255, and I already told you the IO mode. Now, questions will be coming like that. Write down the questions. If port A, sorry, if all the port of 8255, if all the port of 8255 used as a output port, then what will be the value of CWR? Then what will be the value of CWR? Then what will be the value of CWR? I'm repeating once again. All the port of 8255, you know, if all the port of 8255 will be used as an output port, then what will be the value of CWR? Sir, कैसे होगा? कैसे होगा सर?
तो पहले तो
पहले
जो
जो
B17
CWR
है,
मैंने बोला है, पहले इसको इनपुट आउटपुट पोर्ट में जाएगा, मतलब 1
yes,
फॉर
sir.
इनपुट आउटपुट पोर्ट, ओके, और आईओ पोर्ट, इनपुट आउटपुट पोर्ट. Next 2 bit is 0 0.
Yes,
As
sir.
there is a no, handshaking signal is telling about, so we are enter into the mode 0. Enter into the mode 0. Next pin is for
EA
PA.
port A,
Input is required or output is required?
output 0.
0. Next PCR, input or output?
Output 0.
0. Next again mode 0 for port B. Again port B, as a output port. So it will be again, it will be 0. গ্লোসি পেপারে করতে পারতে, গ্লোসি পেপার নেই আর। Okay, and what are the PCL?
PCL will be 0.
0 as the output. So what will be the value? 8 0. So it will be 80. Is it clear to all of you?
Yes, sir.
Very good.
So for port B वाला थोड़ा समझा दीजिए ना।
बोलो बोलो।
तो B वाला जो लिखे हैं पोर्ट B,
पोर्ट
पोर्ट
बी
B का जो उसके पहले जो 4 पोर्ट B मोड जो सेलेक्ट कर रहे हैं,
ये मोड जो पोर्ट बी को तुम मोड 0 मोड 1 किसी में भी यूज कर सकते हो।
ठीक है।
इधर वाला तो हम किया है मोड 0, तो ओवरऑल ये दोनों काम करेगा मोड 0 और मोड 1 में। इसको तुम चेंज करोगे 1 करोगे तो ये पोर्ट भी मोड 1 में भी काम कर सकते हैं। इन जनरल हम लोग नहीं करते, इन जनरल हम लोग मोड 0 इधर करेंगे तो इधर भी हम लोग मोड 0। इज इट क्लियर?
ओके
बट कभी कभी क्या होता है मोड 2 में
Yes.
यूज करने के बाद भी हम लोग इसको मोड 0 में यूज कर सकते हैं और मोड 1 में यूज कर सकते हैं, इसीलिए हम लोग इसको एक ऑप्शन दिया गया है। इसके चलते ये पोर्ट जो है पोर्ट बी, it can be used as a either in input or output or it a hand-shaking signal. That's why there is a mode 0 and mode 1 option is there. So 80.
Okay, sir.
So if all the port is input, then what will be the value, sir?
Input.
So it will be 1, same.
0 0.
It will be same 0 0. It will
Yes,
be
sir.
1. It will
1,
be 1. It will be
1,
0. It will be 1.
0,
It will be 1. So what is value? 1 0 1 1 and 1 0 0 1. 1 0 0 1 is 9 and 1
9.
0 1 1 means it will be 9
in
B.
A. Okay, 9B.
Okay.
Yes, sir.
Next questions also coming like that. If the value of CWR, if the value of CWR is 98H, value of CWR is 98H, बोल के दिया है, right? Then calculate which port input and which port output. Then calculate which port input and which port output. कौन सा पोर्ट तुम्हारा इनपुट होगा, कौन सा पोर्ट तुम्हारा आउटपुट होगा। देन तुमको कैलकुलेट करना है कौन सा पोर्ट तुम्हारा इनपुट एंड कौन सा पोर्ट तुम्हारा आउटपुट। इनपुट कौन सा होगा, आउटपुट कौन सा होगा, क्या होगा, पूरा डिटेल्स में लिखना पड़ेगा। सो
CWR is 9.
first you just break out in a 98H. 1 0 0 1 1 0 0 0. Okay.
Yes, sir.
So 1 is nothing but a IO mode. 0 0 is nothing but a mode 0. 1 is nothing but a PA input. 1 is nothing but a PC upper input. Again group B in mode 0. Again PB. PB क्या होगा बोलो? Output. PC lower output. Is it clear or not? It's clear to all of you?
Sir, repeat one.
Just 98 I am converting into the binary.
Yes, sir.
1001 that is 9 and 1000 that is 8. So 98 I am just converting. Then remember this bit is 1 means it's a IO mode. I'm just mentioning
Yes,
over
sir.
here IO mode. This 2 bit is 00 means mode 0. This bit is 1 means port A input. As I am mentioning over here, if you see the picture, Port A is a 1 is the input, 0 is for output. Port C lower input and 0 output. So just I am given the value is a 1, so PA is the input. As this value is 1, so port C upper is the input. Okay. As this value is 0, so it's a mode 0. At 0 means PB is the output and port C lower is the output.
Yes, sir.
It's clear to all of you?
Yes, sir.
That is the functions actually. How 8255 CWR is worked. Okay.
Yes, sir.
Is it clear?
Yes, sir.
Sir, idhar mein how many students is there, including me?
15, sir.
14. Because 2 is for me, so it's a 14. So I need the name of every hands. So this is right hand of Sudipto. This is right hand, left hand of Sudipto. So right hand and left hand, all the names is there. But for me, there's a different. For me, the Amit is different from Rahul is different. So if I am pointing the Rahul right hand, so I should be mention the name of Rahul and right hand. If I am pointing the left hand of Deepak, so I mention that is the Deepak left hand. Right. Similarly, like that, you should be, whenever you need the hand names, so you should be create a names. According to that, everyone can understood which hand sir is talking about. Is it clear or not?
Yes, sir.
So basically, for this reason, we are basically going in this in the different addressing over here. It's called IO mapped IO. Those 8255 devices actually call IO devices, called input output devices. IO devices. This is not like a memory. So it's a call IO mapped IO. It's a call IO mapped IO. IO mapped IO. IO mapped IO is the address of is nothing but a 8-bit wide. IO mapped IO is nothing but a 8-bit wide. Is it clear? IO mapped IO is nothing but a 8-bit wide. Is it clear?
Yes, sir.
Yes, sir.
IO mapped IO is 8-bit wide. So using the 8-bit wide, sir, हमको बोला गया है सर आप 2 डिजिट में ही हैंड बोल सकते हैं, 2 डिजिट का नंबर ही आप दे सकते हैं. सर मान के चलो इन माय पार्टिसिपेशन लिस्ट अमित कुमार इज द फर्स्ट नेम. So Amit Kumar hand, I am given the name that is Amit Kumar. Right hand is nothing but a 1. Amit Kumar left hand is nothing but a 2. Similarly, Anjali Rani is the right hand is a 3 and left hand is a 4. Deepak Yadav is nothing but a 5, 6. Similarly, Sudipta Chakraborty is 7, 8. Similarly, MD Irfan is nothing but a 9, 10. Similarly, like that. Okay.
Yes, sir.
So 2 डिजिट में हम कितना जन को हम पॉइंट कर सकता हूं?
50.
50 कैसे होगा?
सॉरी, 2 डिजिट में
0 से लेकर कितना दूर तक दे सकते हैं?
9, 10, 5.
3,
हाँ बोलो.
5, sir.
2 डिजिट में तो 0 1 डेसिमल में बोल रहे हैं हम. बाइनरी छोड़ दो. और बाइनरी में बोलोगे तो ऐसा ही होगा. 2 डिजिट में 0 0 0 1 1 0 1 1, यही तो 4 कॉम्बिनेशन हो सकता है. तो 4 तुम पॉइंट कर सकते हो. Am I right or not?
Yes, sir.
इसके और एक तरीका है 2 to the power square is equal to 4. और हेक्साडेसिमल में जाएंगे तो 99 तक कर सकते हैं. अभी इधर 8 बिट बोला है तो बाइनरी बोला है, ये भी बाइनरी में ही है. तो 8 बिट बोला है तो कितना एड्रेस आई कैन जनरेट, हाउ मच एड्रेस वी कैन जनरेट? हाउ कैन एड्रेस वी कैन जनरेट? बोलो.
8.
हाँ,
2 to the power 8.
2 to the power 8. So it's a 256. 256 address I can generate. using IO mapped IO. IO address is 8-bit wide. IO address is 8-bit wide. Remember, there is a combinations of A0 and A1. These two pin are for, 8255. The very vital pin of 8255. If 00, then it will be select port A. If 01, it will be port B. If 10, then it will be port C. And it's a 11, that is CWR. Depend upon A0, A1, port A, port B, port C, and CWR will be selected. Okay.
Yes, sir.
Let's see. Write down the questions. If address of port A, is 80H, address of port A is 80H,
Yes, sir.
then calculate port B, port C, and CWR address. Then calculate port B, port C, and CWR address. Also draw the diagram. Also draw the interfacing diagram with 8085 and 8255. Also draw the interfacing diagram of 8085 and 8255. It's clear?
Yes, sir.
कैसे होगा सर? देखो पहले. First, write down address of port A. Address of port A. Heading करो. उसके बाद लिखो A7, A6, A5, A4, A3, A2, A1, A0. Then convert the 80 into this pattern 1 0 0 0 0 0 0 0. Is it clear? Just 80 converting to the binary. देखो इधर वाला जो है इस side, this side, your left hand side, it will not be changed, but these 2 bit will be changes. For port B it will be 01, for port C it will be 10, for CWR it will be 11. Is it clear?
Yes, sir.
So for port B, what will be the address? 1 0 0 0 0 0 0 1. So that is 8 and that is 1, 81. Is it clear?
Yes, sir.
Next, PC. PC, what will be the value?
1 0
1 0 0 0
0
0 0. It will be
0.
unchanged. Then 1 0. So it will be 8 and it will be 2, 82. Okay. Next, CWR. CWR. What will be happen? CWR 1 0 0 0 0 0
0 0 1
1 1. So it's a 8. It's a 3. 83. It's clear to all of you?
Yes, sir.
Yes, sir.
Next, we should be draw a diagram. Okay, diagram will be drawn in the next page. Will be something right over here. Diagram will be drawn in the next page. So diagram of 8255 interfacing with 8085 and 8255. What will be there? First, you drawn a diagram of 8255. Eight 255. This is port A, this is port B, and this is port C. This is port A, this is port B, and this is port C. Is it clear?
Yes, sir.
Remember the two separate pins. One is PA, one is PA, one one is one is a VCC connected with plus 5 volt, another is ground connected with a ground. Two another separate pin, one is a A0, another one is A1. This is also important pin, as you know, A0 and connected with the A1. These are nothing but a microprocessor pin. These are the nothing but a microprocessor pin, A0 and A1. These A0, A1 is nothing but a 8255 pin. Next, another is data bus, D0 to D7. Here also D0 to D7. It's clear?
Yes, sir.
What will be happen in the next? There is another, remember, chip select pin. In this chip select, same as NAND gate, same as you know the memory interfacing. So how many address bus is left? A2 to A7. Here will not be A2 to A15. This is the IO map. That's why up to A7. Here up to IO map. That's why it's a 8 to 5, you know, A7. So A2 to A7 you should be connected with an AND gate. As A7 is 1, so A7 connected with a direct. Rest all like A6 connected with a NOT gate. You can connect like that also NOT gate, no issue. A5. Another is A4. Another is A3. Another is A2. You connect either this kind of NOT gate or that kind of NOT gate. No issues for that. It is basically same. But A2 to A7. Why A2 to A6 are connected with the NOT gate? If you see the, you know, the value here, A2 to A6 all are 0. And A7 is 1. When it will be become 0? When this output of NAND gate is become 0? When? NAND गेट में कब आउटपुट 0 होता है?
जब सारा सेम होता है,
जब
सारा इनपुट सेम होता है,
जब सारा इनपुट 1 होता है, सारा का सारा 1 होगा. तो इधर तो 1 है ही, तो इसीलिए डायरेक्ट. इधर में सारा 0 था, इसको 1 करने के लिए मैंने सारा को सारा नॉट गेट लगाया. Is it clear?
yes sir.
So this is the diagram of 8255. These are the pin of 8085 connected. That's why this is the interfacing of 8085 and 8255. No need to draw the diagram of 8085. These are the pin of 8085. These are the pin of 8085. You can mention over here 8085 mu p, or you cannot. No issues for that. Because this side is 8085, this side is 8255. Okay? It's clear to all?
Yes.
Now question is coming. If address of port A, if address of port A if address of CWR, if address of CWR is D7H, address of CWR is D7H, then calculate PA, PB and PC. Calculate PA, PB and PC. How it will be done, sir? Again, A7, A6, A5, A4, A3, A2, A1, A0. and it's a CWR. So CWR D7 is nothing but a 1 1 0 1. That is D. 7 means 0 1 1 1. This is for CWR. Sir, what are the combination is required for A0 A1 for CW1? CWR? What are the combinations of A0 A1?
1 1.
1 1. So it's a 1 1.
Yes, sir.
No problem at all. So up to that unchanged, then this 2 bit will be changed. So 1 1 0 1 0 1 1 1 0 1 0 1 1 1 0 1 0 1. What will be the for port A, A1 and A0?
0
0 1
Port A
0 0.
0 0
0 0.
0.
So I'm putting over here 0 0. For port B
0 1
0 1. So it's
0
a
1.
1. For port C
1 0.
1 0. So what will be the value?
1
It's a
0.
D. It's a port A. It's a port B. It's a port C. So what are the value of it? You know, in hexadecimal, 1 1 0 1 0 1 0 0 means D
4.
no D4, right? Sir, in B, next one
D5
D5.
D5.
Next one, sir,
D6
D6.
D6.
Okay, these are
Yes,
the
sir.
address. Next, what will be the diagram? You can draw. You draw the diagram. I will be tell you how to do it. Only the NAND gate will be changed. Rest all are will be the same. Up to that, there will not be any change. Up to this portion, that will be same. Changing over here, I am drawn this NAND gate will be replaced by another NAND gate. It will be like that. Sir, A7 1 or 0?
1, sir.
1. A6 also 1. So A7 and A6 both are directly connected. Okay. A5, sir,
0.
0
0.
Not yet.
Next, sir, A4
1
1.
1. So that is also direct. Next, sir, A3
0.
0
0. So connected with a NOT gate. Sir, A2
A2 1
1.
A2 1. Connected direct. This NAND gate will be replaced by this NAND gate. This NAND gate will be replaced by this NAND gate. Rest of the diagram will be the same. Rest of the diagram will be same. Only this NAND gate will be replaced by this NAND gate. It's clear to all?
Yes, sir.
Yes, sir.
Sir,
Yeah.
so if CWR is D6H, then
D
6.
D6. I will be coming into the next. Okay, I coming in the next to next diagram. Okay. Okay, I am coming in the next. No issues for that. If the address of port A, if the address of port A is C2H, if address of port A is C2H, if address of port A is C2H, okay, address of port A is C2H, then calculate the port B, port C and CWR according, and draw the interfacing diagram. Here, what will be the address of port A? A7, A6, A5, A4, A3, A2, A1, A0. Is it clear? Is it clear to all of you?
Yes, sir. Yes, sir.
Yes, sir.
So, what will be the C2? 1, 1, 0, 0, 0, 0, 1, 0. Am I right?
Yes, sir.
Yes, sir.
Sir, what will be the port A of A0 and A1? क्या है सर पोर्ट ए के लिए? A0 A1 क्या होना चाहिए?
0, 0.
0, 0 होना चाहिए, मगर है क्या?
1, 0.
1, 0. यही तो क्वेश्चन था ना राहुल तुम्हारा?
Yes, sir.
ऐसा प्रॉब्लम आने से कैसे करेंगे? ठीक है, अभी इसका डायग्राम पहले ड्रॉ करते हैं, उसके बाद हम एड्रेस निकालेंगे. पहले डायग्राम. दिस इज 8255. PA, PB, PC. सर देखो, इसमें हम कोई एरो नहीं लगा रहा है, क्यों बोलो तो?
Unidirectional.
नो, ये डिपेंड करेगा CW आर का कितना वैल्यू है. इधर इनपुट होगा, इधर आउटपुट होगा. आउटपुट होगा तो ऐसा एरो होगा, इनपुट होगा तो ऐसा एरो होगा. तो हम कुछ भी नहीं डाल रहे हैं.
Yes, sir.
डेटा बस ऑलवेज बाई डायरेक्शनल, दैट्स व्हाई हम देखो बाई डायरेक्शनल बस दे रहे हैं. D0 to D7 and D0 to D7. Next, A0 connected with A0. A1 connected with a NOT gate with A1. क्यों बोलो तो सर? होना चाहिए था क्या? A1 क्या होना चाहिए था?
0, 0. A1 0 होना चाहिए.
0 सर.
0 होना चाहिए था, मगर है क्या?
1 है सर.
1.
1.
नॉट गेट लगाया, मतलब 1 देने से इसको 0 मिलेगा. इधर में हमको टर्मिनल में 0 0 मिलना चाहिए, जो हम मिला दिया. राइट?
Yes,
तो
sir.
पोर्ट बी का एड्रेस क्या होगा? A7, A6, A5, A4, A3, A2, A1, A0. 1 1 0 0 0 0. ये तो अनचेंज, इसका तो कोई लेकर कोई बात ही नहीं है. A1 क्या होगा बोलो? क्या होना चाहिए था? 0 1 होना चाहिए था.
1 1 हो जाएगा.
1 1 हो जाएगा. 0 1 होना चाहिए था. ये तो कोई चेंजेस नहीं होगा, जो होना था वही होगा, क्योंकि डायरेक्टली कनेक्टेड. A1 नॉट गेट से कनेक्टेड, दैट्स व्हाई जो होना था उसका ऑपोजिट देना पड़ेगा. 0 होना चाहिए था, मैंने 1 लगाया, तो हो जाएगा C3. सर PB हो गया. PC क्या होगा? 1 1 0 0 0 0 0 0.
Yes, sir.
That is C0. राइट? तो CWR क्या होना चाहिए? 1 1 0 0 0 0 0 1. So C, it's a C and it's a 1. It will be C1. It will be C1. Sir, there is a missing in diagram. There is a NAND gate. NAND gate, you all of you know, it is a very simple. These two connected directly, and these four connected with a NOT gate. These four connected with a NOT gate. That is the whole diagram. It also connected with a CS bar. Right? And VCC and ground both are there. Is it clear to all?
Yes, sir.
all are done is nothing but a IO mapped IO. Full form इनपुट आउटपुट एड्रेस से हम इनपुट आउटपुट डिवाइस को कनेक्ट कर रहा है. इनपुट आउटपुट एड्रेस 8 बिट का होता है. इनपुट आउटपुट एड्रेस भी हम डिवाइस भी कनेक्ट कर रहा है जैसे 8255 एंड ऑल. So you know in 8085 all the 8255 port, 8255 port, 3
Yes,
port, that is a port A, port B and port C. So port A, port B, port C are nothing but a it's a maybe input, maybe output, maybe different, but it sometime it will be act as a IO mapped IO, sometime it will be act as a memory mapped IO. Now I am coming into the memory mapped IO. Now I am coming into the memory mapped IO. Write down the questions. In 80, if the address of port A, if the address of port A is 8FF0H, 8FF0H, then calculate if the address of port A 8FF0H in memory mapped IO, in memory mapped IO, in memory mapped IO, then calculate PB, PC and CWR. Also draw the diagram. Also draw the diagram. Also draw the diagram. Also draw the diagram. It's clear to all of you?
yes, sir.
Sir, how it will be done? First, same as previously done. Address of port A is nothing but A15, A14, A13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Okay. 8FF0 means 1, 0, 0, 0, 1, 1, 1, 1, 1, 1, 1, 1, 0, 0, 0, 0. Am I right? This is 8FF.
1 होगा सर.
Huh?
सर A3, A2, A1, A0 में भी नहीं सर. ठीक है सर.
This is 8. 4, 1 means F. 4, 1 means F. Last 0, 0, 0, 0. So if I'm talking about the port B address, then up to A2 unchanged. So 1, 0, 0, 0, 1, 1, 1, 1, 1, 1, 1, 1, 0, 0. And the last 2 bit will be 0, 1. So what will be the address? 8 F 1, 8FF1. This is for port B. What will be a port C? 1, 0, 0, 0, 1, 1, 1, 1, 1, 1, 1, 1, 0, 0, 1, 1. That is 8 F 0, FF2. What is CWR? 1, 0, 0, 0, 1, 1, 1, 1, 1, 1, 1, 1, 0, 0, 1, 1. So that is 8 F3. It's clear to all?
Yes, sir.
It's clear to all?
Yes, sir.
Yes, sir.
So this is the address of port A, port B, port C, and CWR. Diagram you also can draw. Only difference is that here A2 to A7, A2 to A7, but in this diagram, what will be there? A2 to Bolo Ansari? A2 to A2 to A15. A2 to A15. Very good. So you know this diagram is in IOMAP A2 to A7, but in this diagram it will be A2 to A15. जो 1 है वो direct होगा, जो 0 है उसको not get लगाना पड़ेगा. Same formula. It is done. Next, the very important questions: what are the difference between IO mapped IO and memory mapped IO? What are the difference between memory mapped IO and IO mapped IO? Write down the questions. What is the difference between memory mapped IO and IO mapped IO? Difference between IO mapped IO and memory mapped IO. IO mapped IO and memory mapped IO. Sir, how many devices can connect using IO mapped IO? Bolo? How many devices can connect in IO mapped IO? Huh? Bolo? I'm not hearing with you. 2 to the power 8. I've already told to you that is 256 devices. And memory में प्रायो कितना बिट का एड्रेस है सर? ये कितना बिट का एड्रेस था?
16.
16. 2 to the power 16 memory devices, sorry, 2 to the power 16 devices can connect. Okay. Instructions. Example of instruction like in 80, out of 40, something like that. Example of instructions. So example of instructions like STA 8500H, LDA 8600H. तो सर कितना बाइट का इंस्ट्रक्शंस है ये? बोलो कितना बाइट का इंस्ट्रक्शंस है?
2 bytes.
2 byte. All the instructions are 2 byte. All the instructions are over here
3 bytes.
3 byte. Okay. Next, बाइट ज्यादा है तो मशीन साइकिल ज्यादा लगेगा, तो टाइम भी ज्यादा लगेगा. over here is faster. So it's a faster, it's a slower. It's a faster and it's a slower. And number 5, address address bus 8-bit wide, address bus 16-bit wide, address bus 16-bit wide. That is the whole difference of IO mapped IO and memory mapped IO. Using 8255, we are done several interfacing. As you know, microprocessor is called Jagannath, so it cannot connect without 8255. If you want to connect or interface with any other devices, so first you should be connect with 8255, then you can connect with the other devices. And next we are coming into the another processor, that is 8086. Another processor, that is 8086. तो 8086 में क्या होगा सर, बोलो बोलो। हम्म 8086 में क्या होगा? एड्रेस बस कितना बिट का होगा?
20
20 बिट। डेटा बस कितना बिट का होगा? बोलो।
8
16 बिट। मैंने
16
बताया था पहला दिन जब पहला
yes sir
क्लास हुआ था। मेमोरी कैपेसिटी 2 to the power 20 into 8 बिट करके आएगा 1 मेगाबाइट, वो भी मैंने दिखाया था 1 मेगाबाइट। इज इट क्लियर?
yes sir
So these are the three parameter which we should be take care of in a year. And clock frequency 5 to 10 megahertz. Clock frequency 5 to 10 megahertz. Okay, is it clear to all of you? Clear to all of you?
yes
sir.
sir
Okay. Next, unlike 8085, 86 is a different. 86 have a different features, different functions. Everything is different. So first in 8086, support the pipelining architecture. Support the pipelining architecture. So what is the pipelining architecture? Anyone have any kind of knowledge regarding the pipelining architecture? Regarding the pipelining architecture? Actually, say I give a work to 3 person, say like Ansari, Rahul, and Deepak. I given a work to these 3 person. Work is nothing but to clear the Deepak room. To clear the Deepak room. Okay. So Deepak room clear means Deepak का room में hostel में मान के चलो क्या क्या है, बेड है, गद्दा है, टेबल्स है, चेयर्स है, सारा कुछ है। तो इसको साफ सफाई करना है, पेंटिंग करना है, तो क्या करना पड़ेगा? पहले सामान को क्या करना पड़ेगा?
बाहर करना
सामान बाहर करना पड़ेगा। वेरी गुड। तो एक काम हो गया सामान बाहर करना। इसके बाद क्या करना पड़ेगा? घर के अंदर पेंटिंग करना पड़ेगा, फ्लोर सफाई करना पड़ेगा। ये दूसरा काम हो गया, राइट। और तीसरा क्या काम होगा? बोलो।
वापस से सामान को अंदर करना।
वापस सामान को अंदर करना। अभी तुम लोग आपस में डिवाइड कर लिए हो एक क्लास, एक काम से आंसारी बोला जो आई विल बी गेट ऑल द मटेरियल्स इन द आउटसाइड, मतलब सारा सामान जो है उसको लेकर आउटसाइड में आ जाएगा। दीपक ने बोला मैंने पेंटिंग कर देंगे, एंड राहुल ने बोला जो सामान है वो हम फिर से अंदर कर देंगे। तो इन तीनों का एक्चुअली फंक्शंस है, इन तीनों इधर में काम करेगा। तो जब मान के चलो आंसारी इज डूइंग द वर्क, तो बाकी दो क्या कर रहा था? बाकी दो सो रहा था, राइट। After complete answering work, Ansari given a pink to Deepak. Just you get up and do the painting and all. तो दीपक उसके बाद थोड़ा पेंटिंग शुरू किया, राइट। दीपक पेंटिंग किया। पेंटिंग करने के बाद दीपक फिर जाके किसको बोलेगा? राहुल को बोलेगा जस्ट यू डू योर वर्क। एम आई राइट?
yes sir
देन राहुल सामान लेकर आएगा। तो कितना टाइम लगेगा ये अप्रोक्सीमेट? से 1 आवर लगेगा, से 1 आवर लगेगा। हम ऐसे 4 रूम देंगे तो कितना आवर लगेगा?
4 सर।
4 आवर लगेगा। वेरी गुड। देखो तो काम ऐसा हो सकता है कि नहीं, रूम थोड़ा बड़ा है, एक साइड जब क्लियरेंस कर दिया आंसरी, तब उस जगह में दीपक क्यों नहीं पेंट कर सकता है? अंसारी धीरे धीरे निकालते जा रहे हैं या दीपक उसी साइड में पेंटिंग एंड फ्लोर क्लीनिंग जो जो करना है सारा करते जा रहे हैं। एंड जब उसका पेंटिंग एंड फ्लोर क्लियरिंग हो जा रहा है, तब अंसारी ये राहुल ने क्या कर रहा है, सामान अंदर पैक करते जा रहे हैं। जब दीपक इसी रूम में था, अंसारी दूसरा रूम में चला गया, वो भी सामान निकलना शुरू कर दिया दूसरा रूम का, राइट। दीपक होने के बाद दूसरा रूम में चला जाएगा, अंसारी होने के बाद भी दूसरा रूम में चला जाएगा, उस उतना देर तक शायद अंसारी गोइंग इनटू द 4th रूम। तो ऐसा हिसाब से करने से थोड़ा कम टाइम लगता था कि नहीं?
यस सर।
इसी को बोलता है पाइपलाइनिंग आर्किटेक्चर, एक्चुअली कमिंग फ्रॉम द वाटर पाइपलाइनिंग। जब भी तुम लोग कॉल खोलोगे कांस्टेंट रेट में पानी निकलेगा, ऐसा नहीं है 2 मिनट निकलेगा 3 मिनट बंद रहेगा। इसी को बोलते हैं हम लोग द पाइपलाइनिंग। अभी देखो पाइपलाइनिंग कैसे होता है। एक इंस्ट्रक्शन का 3 फेज होता है, फेचिंग, डिकोडिंग एंड एग्जीक्यूशन। फेचिंग, डिकोडिंग, एग्जीक्यूशन। फेचिंग, डिकोडिंग, एग्जीक्यूशन क्या है बताओ तो? किसी को याद है? मैंने बोला था फेचिंग, डिकोडिंग, एग्जीक्यूशन।
इनपुट दे रहे हैं तो फेच कर रहे हैं,
हाँ,
इनपुट ले रहे हैं तो फेच कर रहे हैं,
सुना ही नहीं दे रहा है।
तो इनपुट ले रहे हैं तो फेच कर रहे हैं।
इनपुट ले रहे हैं तो फेच कर रहे हैं ना, थोड़ा ऐसा नहीं है, फिर भी हम बोल रहा हूँ, सुन लो बढ़िया से। Fetching is nothing but a like, what is your name? You just listen my word. This is called fetching. मतलब जो इंस्ट्रक्शंस दिया वो इंस्ट्रक्शंस रजिस्टर में आएगा, ये है फेचिंग। देन तुम क्या करोगे? तुम सोचोगे सर क्या पूछ रहे हैं? सर पूछ रहे हैं हमारा नेम, हमारा नेम क्या है? मतलब यू आर कन्वर्टिंग इन योर ओन लैंग्वेज। मे बी हमारे बारे में बोलोगे, एज आई एम ए बंगाली, आई विल बी थिंक लाइक दैट, আমার নাম জিজ্ঞাসা করছে, means something like that. So different machine have a different machine language, so convert this into the machine level language, it's called decoding. And last, my name is Rahul, my name is Ansari, my name is Sudipta. So these are the nothing but execution. So every instruction have a 3 phase: fetching, decoding, execution, fetching, decoding, execution, fetching, decoding, execution. This is done in 8085. एक का फेचिंग होगा, उसका डिकोडिंग होगा, उसके एग्जीक्यूशन होगा, उसके बाद नेक्स्ट इंस्ट्रक्शन का फेचिंग शुरू होगा, डिकोडिंग शुरू होगा, एग्जीक्यूशन शुरू होगा, ऐसे चलते रहेगा। इज इट क्लियर और नॉट? इट्स क्लियर टू ऑल ऑफ यू?
यस सर।
सो इसलिए 8085 को बोलता है सीक्वेंशियल आईसी। क्या बोलता है? सीक्वेंशियल आईसी, सीक्वेंशियल आईसी। 86 में क्या होता है? फेचिंग कोई करके जाता है, डिकोडिंग कोई दूसरा करेगा, डिकोडिंग एंड एग्जीक्यूशन एक करेगा। वन टू थ्री, 1 1 2 2 3 3। हम हर एक ब्लॉक के नीचे ब्लॉक बनाएंगे तो ये 2 ब्लॉक कम लगे, मतलब कम लगेगा, नहीं लगेगा ये 2 ब्लॉक, ये लास्ट 2 ब्लॉक। So this is nothing but a save time in 8086. If I am talking about the 3 instructions, that's why these 2 block. If I am talking about the 5, 10, 15, 20, 100, 200, 400 instructions, then this block will be increased. Then this block will be increased. It is clear to everyone?
Yes, sir.
Yes, sir.
So my question is that this is called pipelining architecture. This is called pipelining architecture, which is done in 8086. ये जो काम करता है, ये architecture is dividing into the two part. Architecture is dividing into the two part. One part, this part is called bus interface unit, BIU. This part is done by the BIU, and this part is done by EEU. Full form, execution unit. This part is done by the BIU, this part is done by the EU. Full form, execution unit. Bus interface unit and execution unit. This part is done by BIU, this part is done by EU. Full form, execution unit. Is it clear?
Yes, sir.
Yes, sir.
So bus interface unit and execution unit. That is the functions of bus interface unit. That is the function of execution unit. So fetching all the data, then decoding executions. So it is called, pipelining architecture. So you can maybe find, thinking that why not it is done in 8085. 8085 में क्यों नहीं हो पाया था? Is it clear? My question is clear to all.
Yes, sir.
It's clear to all.
Yes, sir.
क्यों नहीं हो पाया था? क्योंकि उस टाइम में टेक्नोलॉजी उतना एडवांस नहीं हुआ था, इसी का कारण नहीं हो पाया था. टेक्नोलॉजी एडवांस हुआ, इसके चलते हो पाया है. नेक्स्ट तुम लोगों का ये भी मन में आ सकता है, सर ये डी ब्लॉक को थोड़ा इधर क्यों नहीं शिफ्ट कराया, इसके नीचे क्यों नहीं हुआ? बोलो तो क्यों नहीं हुआ?
सर क्योंकि फेचिंग का वर्क कंप्लीट होगा तभी डिकोडिंग स्टार्ट होगा.
सिमिलरली लाइक योर एग्जांपल, जब तक अंसारी ने सामान नहीं निकाल रहा है तब तक दीपक का कोई फंक्शन नहीं है. एक भी सामान नहीं निकलेगा तो कोई फंक्शन नहीं है. एक साइड खाली करेगा तो उसी साइड से वो पेंटिंग करना शुरू करेगा. एम आई राइट?
यस सर.
Yes, sir.
फेचिंग करेगा तब भी अगर होगा. अच्छा, ये फेचिंग डेटा कोई एक जगह स्टोर करके रखना पड़ेगा. मान के चलो आई एम सिटिंग इन 6th फ्लोर. 6th फ्लोर में हम अभी बैठे हुए हैं एग्जैक्टली. तो हमारा घर सफाई करना है, मगर हमारा घर के बाहर में कुछ है ही नहीं. हम नीचे से मतलब हेलीकॉप्टर से 6th फ्लोर में आए, और जाने का टाइम हेलीकॉप्टर से ही जाएंगे. अभी जो सामान निकलेगा तो बाहर निकालेगा तो क्या होगा? सामान
गिर जाएगा.
नीचे गिर जाएगा, तो डिस्ट्रॉय हो जाएगा. तो बाहर में एक जगह रहना पड़ेगा. एम आई राइट?
यस सर.
और बोलो तो राहुल कौन सा सामान को पहले निकालेगा? सॉरी, राहुल का क्या काम था?
सामान को रखना.
सामान को रखना. तो राहुल कौन सा सामान को पहले रखेगा? बोलो. वेरी
बेड
सिंपल
को.
क्वेश्चन.
बेड को.
ना बेड तो अलग चीज है. जो देखो, सोचो पहले से एक साइड का सामान पहले निकल गया. उस टाइम में दीपक पेंटिंग कर रहा था, राइट?
यस सर.
दीपक पेंटिंग उस जगह में खत्म होने से उस जगह तो मैं अभी सामान रख सकते हैं. अभी तक अंसारी सामान निकाल ही रहा है, अभी तक उसका सामान निकालना खत्म नहीं हुआ. अभी राहुल कौन सा सामान को अंदर करेगा? जो सामान पहले निकले था, जो सामान
Yes,
पहले
sir.
निकला था उसी को अभी पहला घुसाएगा.
यस सर.
मतलब first in first out, first in first out. That means there is a queue. So in 8086, to store this fetching data, we have a 6 byte long queue. 6 byte long queue we have to store the fetching data. 6 byte long queue. Is it clear? Is it clear to you?
यस सर.
Right. So next, so this is a pipelining architecture. Another questions you are not asking. You have any questions?
नो सर.
That's the biggest problem for me. क्वेश्चंस नहीं करोगे तो कैसे होगा? सर इसमें और एक चीज कर सकते थे जो नहीं किया इधर, डी कोड को इस लाइन में थर्ड लाइन में एग्जीक्यूशन को क्यों नहीं रख सकते थे? Is it clear? My question is clear to you. D
Yes,
in
sir.
this line and E will be in the next line, so some block will be reduced. Am I right? Remember, from 80286 and upward, all the processor we are doing the same, decoding in the second line and third line will be the execution only. But whenever 80286 technology enhance up to that positions so that it can be done. So 8086 is nothing but it's a BIU and it's a U, and it's nothing but a two part. One is the fetching, another is decode and execute, decode and execute, decode and execute. In the 80286 and upward, all the processor decode in the second line and third line is execution. It's clear to all? It's clear to all?
Sir, repeat once.
देखो मैंने जो क्वेश्चंस किया था, ये जो डी हो रहा है, तो मैंने बोला
Yes, sir.
डी इस लाइन में, ई नेक्स्ट लाइन में नहीं हो सकता था, तो ब्लॉक
हो
ज्यादा
सकता-
कम लगता था, इतना नहीं लगता
Yes,
था,
sir.
इससे थोड़ा कम लगता था.
Yes, sir.
तो 8086 में ये नहीं है, 80286 एंड अपवर्ड ऑल द प्रोसेसर में ऐसा ही है, थोड़ा कम लगता है, राइट?
Okay.
That is the functions. Next is register. If I am talking about the register, 8085 में कितना registers है? Sorry, 8086 में address bus कितना है? 20 bit. 8085 में कितना था? 16 bit. 8086 में सबसे बड़ा रजिस्टर का लेंथ क्या था? रजिस्टर और रजिस्टर पेयर का जो सबसे हाईएस्ट था,
BC
बीसी कितना
BE
कितना बिट का है?
16.
16 sir.
16 बिट. जैसे एसपी है, जैसे पीसी है, वो डायरेक्ट 16 बिट का है. Am I right?
Yes, sir. Yes, sir.
तो ये 16 बिट रजिस्टर से 16 बिट एड्रेस को पॉइंट करना कोई प्रॉब्लम नहीं था, आसान काम था. 16
Yes,
बिट
sir.
रजिस्टर भी था, 16 बिट एड्रेस बस भी था, कोई भी एड्रेस के कोई भी रजिस्टर से पॉइंट कर पाते थे. मगर इसमें थोड़ा प्रॉब्लम है, क्या प्रॉब्लम है? एक मिनट, हेलो, हाँ, my
Yes, sir.
problem is clear to you?
Yes.
तो 6 बिट एड्रेस से 16 बिट एड्रेस बस को पॉइंट करना बहुत आसान था, मगर
Yes, sir.
ये एड्रेस बस से ये एड्रेस को पॉइंट करना थोड़ा मुश्किल ही है. इज इट क्लियर? 16 bit, if you have a 16 bit operation, then AX will be act as a accumulator. If you are working in a 8 bit operations, then AL will be act as a accumulator. Is it clear?
Yes, sir.
Yes, sir.
Similarly, BX also used as a offset storage. General purpose register, general purpose storage use मतलब एडिशन, सब्सट्रैक्शन, मल्टीप्लिकेशन, डिवीजन सब कुछ करने के लिए ये चारों रजिस्टर्स है. कोई डेटा को टेम्पोररी स्टोर करने के लिए भी यही रजिस्टर है. So BX used as a general purpose register as well as offset storage. My second part is a segment register. My fourth part is offset storage. Offset register. Segment register and offset register. So in a general purpose register, BX also used as an offset register. General purpose register as well as offset register. CX used as a by default counter. CX used as a by default counter, and DX used as a DH and DL. DX used as a DH and DL. Means it will be act as a higher 8 bit of DX is act as a DH and lower 8 bit of DL. DX also used as an implicit operation like multiplication, division operations. DX is used. So every register as a general purpose register and some other functions like AX used as a general purpose register as well as accumulator. BX used as a general purpose register as well as offset storage. CX used as a general purpose register as a by default counter. DX used as a general purpose register as well as in implicit operations. Whenever I'm doing any program or instruction, it will be clear to all of you. In the segment registers, we have 4 segment register: CS, DS, SS, and ES. Full form: code segment, data segment, stack segment, extra segment. Code segment, data segment, stack segment, extra segment. There are 4 register: code segment, data segment, stack segment, extra segment. Is it clear? Code segment is nothing but a
Yes, sir.
code segment is nothing but a code segment. Just write down the name: code segment, data segment, stack segment, and extra segment. I will be explained later on. I'll be explaining later on what are the functions. You just write down the name: code segment, data segment, stack segment, and extra segment. And in the offset register, you have like that: IP, instruction pointer, number 2, BP, sorry, SI, number 3, DI, number 4, BP, number 5, SP, number 6, BX, and number 7 is direct. IP full form is a full form of instruction pointer. SI is a source index. DI is a destination index. BP is a base pointer. SP is a stack pointer. Instruction pointer, source index, destination index, base pointer, stack pointer. Is it clear? It's clear to you?
DI, sir.
DI is a
DI.
destination index. Source index, destination index. Instruction pointer, source index, destination index, base pointer, stack pointer.
So BX.
BX, general purpose register. General purpose register.
Yes, sir.
Here same. It's a general, there is
Yes.
a no name. And direct means you can give the address directly. Today the next topic is what are the function of CS, DS, SS, ES, and how it will be worked with that, and how generate the physical address. Tomorrow I will be discussed. Not tomorrow, it will be in Monday. I think your class is in Monday. Okay.
Yes, sir.
Okay, and I'm just give me 1 minute. I'm taking your attendance. Okay, bye for today, and we'll be meet again on Monday. Okay.
Okay, sir.
Okay, bye bye.
Thank you, sir.
Thank you, sir.
Okay, most welcome to all of you.